Application 3. Atwood machine. The atwood machine is a device that demonstrates the basic principles of acceleration and dynamics. You will mostly see atwood machines in physics laboratories and classrooms. It consists of two objects with different masses that hang vertically from a frictionless pulley that has a very small or negligible mass. The atwood machine is a very common device in physics labs. Its structure is quite simple because it only contains 2 to 3 components. This machine is typically composed of a string, a pulley, and a system of masses. The most basic atwood machine consists of two objects that are connected by a light inextensible cord that passes over a pulley which is frictionless. Now, let us see the problem related to atwood machine. Atwood machine consists of two masses, M1 0.55 kg and M2 0.8 kg. Both masses are suspended from a fixed frictionless pulley as shown in the figure. What is the first one? What is the acceleration of the system? And B, what is the tension in the string? Okay, Atwood's machine. What is Atwood's machine? Normally, Atwood's machine consists of two masses. Okay, in this case, the mass 1 is 0.55 kg and mass 2 is 0.8 kg. The two masses are connected with one string. Okay, and there is a tension force here, which the value of the tension force is T. Both are same. So this is T, this is T. So from these problems, you are asked to find the acceleration of the object, okay, and the tension of the string. By seeing this figure and the value of this mass, by logic we know that M2 will move downward and M1 will move upward. So this is the acceleration of M1 and M2. Okay, so in these problems, we still consider any force in the direction of motion is positive. Okay, the first one, what you should do is, as usual, the first one is FBD. So FBD is important for you to solve the problem. Okay, it makes it easier to recognize which one involved in the calculation, which forces involved in the calculation. So now let us do FBD for object 1. So M1, this is for M1 first. The force that act on the object in the direction of motion is, one is T, and then another one is M1G. So what is the value of M1G? Let us calculate it first. M1G, M1 is 0.55 times 9.81. The value is 5.395 Newton. Okay, this is the FBD for object 1. So FBD for object 2. M2. So this is T and this is the gravitational force of object 2, M2G, where the value is M2 is 0.8 times 9.81. The value is 7.85. 7.8. second step, we have to do an equation. We have to write we have to apply, second step. For the second step, we have to apply the Newton's second law of motion for both objects. Okay, for object 1, apply the net force is equal to MA for both objects. So, object 1, M1. The net force is equal to MA. Okay, so the net force is equal to M1A. So the net force here, what is the equation for the net force? The net force is T minus T is positive because the direction of motion for M1 is upward motion. So T minus M1G is equal to M1A. Okay, so from here you will get T is equal to M1A plus M1G. So M1 is 0.55 A, then plus M1G 5.395. Okay, this is first equation. This is the equation from object 1. And then let us see the equation for object 2. Now we apply the Newton's second law of motion equation for object 2. So net force will be M2G minus T. M2 will be positive because it is in the same direction of motion. So M2G minus T is equal to M2A. So here 7.85 minus T is equal to 0.8 A. Alright, so this is the second equation from object 2. So now we will do the simultaneous equation for both equations. By doing simultaneous equation, you can get the acceleration and tension. So now let us do one by one. Okay, so I substitute the value of T into equation 2. So it becomes 7.85 minus 0.55 A plus 5.395 A is equal to 0.8 A. So when you calculate here, it becomes, okay, let us calculate together. 7.85 minus 5.395. So here is 2.455, right? 2.455 is equal to, so 0.8 A plus 0.55 A is equal to 1.35 A. And A here is equal to 2.455 divided with 1.35. So you will get the acceleration is 1.82 meter per second square. This is the acceleration experienced by both objects, 1.82 meter per second square. And then to find the tension, we have to substitute the value of A inside the first equation. So T will be 0.55 times the acceleration A, 1.82 plus 5.395. Here you can get the acceleration is 0.55 times 1.82 plus 5.395. 6 point, the tension of the string is 6.396 Newton. Or you can simplify it, round off the value, you can get 6.4 Newton. Alright, so this is the tension of the string in this problem. So thank you for watching. Have a nice day.